This is higher computing, computer systems, and it's the computer structure section. First lesson's on the processor, and as you can see from this diagram, there's a very simple computer system diagram with the processor in the middle. The input devices feed in, the calculations or the changes to the data are then sent to either main memory, backing storage, or output devices. And main memory and backing storage have a two-way process where data can be read from or written to backing storage or the different types of main memory. But we're concentrating on the processor today. It's made up of three main parts: the control unit, the ALU, and the registers. The control unit is the brains of the computer. It basically controls the instructions that are sent, or controls the different peripherals that are connected to the machine, and also synchronizes the events and instructions that are in the system. The ALU is short for arithmetic and logic unit, and what that does is it handles all the mathematical and logical operations. And the third part of the processor is the registers, and these are short-term areas of small areas of memory where it can hold things like data to be processed, instructions that are being executed, and addresses to be accessed. There's a few key ones you need to know about. Firstly, you've got the MAR, which is short for Memory Address Register, and obviously that holds the addresses that are currently being accessed. MDR is short for Memory Data Register. That holds data being processed or data that's about to be written to or read from the main memory. And thirdly, we've got the instruction register, and that holds instructions that are currently being executed. I call them Columbo's pockets because they're like, if you've seen the Columbo films, he's always sort of got little scraps of paper in his pockets, and they're small pieces of information that are very close to hand. And it's a nice analogy for registers. Now, connecting the processor to main memory, you've got some data buses. You've got some buses and you've got control lines. Now, the two buses you need to know about are the address bus, which holds the addresses to be accessed, and the data bus, which holds data that's either going to or coming from main memory. As you can see from the diagram, the address bus goes up the way only, which means it's unidirectional. It's going from the processor to main memory, whereas the data bus is going to main memory and from main memory. So you can write data to and read data from, but you never get an address back from main memory on the address bus. It's only the address that's being accessed or the address that's being written to comes from the processor, goes to main memory. Now, in the middle you've got 6 lines called control lines. But these are flags that tell main memory what is actually going on, and it just keeps basically just little instructions that tell it what to do. They're a bit like Butler's bells, if you can remember those. The first one's the read control line, and what that does is it tells main memory that a read operation is about to take place, and so to look out for an address on the address bus, but there'll be no data coming to memory on the data bus. It's to send it back. There's more on this in the fetch execute cycle a little bit later on. Similarly, with the write control line, it tells the main memory that a piece of data on the data bus is about to be written to an address which has been held on the address bus, and nothing has to be sent back. The clock is basically is sort of like a steady pulse which synchronizes instructions and the transfer of data to and from main memory. You've got reset, which clears the processor of any existing instructions and data from the registers. You've got interrupt and non-maskable interrupt. Now, these two can be used to tell the processor to stop its current action to perform another action, or the task that's performed the interrupt. Now, the difference between the two is that the top one, the highest one, the interrupt, can be ignored, but the non-maskable interrupt cannot be ignored. An example of a non-maskable interrupt would be a power cut, or a program crashing, or the reset button being pressed on your PC. So these things cannot be cancelled or cannot be paused or delayed. So with a non-maskable interrupt, what happens is that the processor very quickly saves its current state, so whatever's in the control unit, the ALU and the registers, and then performs the task that it's been asked to do, which could be shut down the machine. With regards to the interrupt, this is for things like, for example, if you're running an internet browser and an email client, and you're looking at a news website, and in the background your email just checks the inbox basically, and it'll maybe play a sound or show a little preview of a message that's just arrived. That's an example of an interrupt. So it's something which could be ignored by the processor because it's not seen as being urgent. But so if it was running something really important, it might delay execution of the new email sound or new email message. But if there's a bit of free time on the CPU, or if the current task is not seen as a priority or urgent, then it will stop the process, interrupt it, perform the new email sound or new email preview or notification, and then continue with the web browsing. So you need to know about the difference between the two types of interrupts, and so using examples is a very good way of doing that. So hopefully you understand the different flags or control lines that we have on the processor. And that's about it. So already you should know a lot more about what happens inside the processor. It's no longer a black box. It's made up of three parts: the ALU, the control unit, and the registers. And you should know examples of some registers. You should also know about the buses, so the address bus, the data bus, and the control lines that connect the processor to main memory. And in the next lesson, we are going to look at the different types of memory and why having memory close to the processor is a better idea than having it further away from the processor, with regard to sort of operating speeds and things like that.